In these notes, we are going to be able to graph quadratics in standard form. Our first vocabulary word is a quadratic function is a function that can be written in the form ax squared plus bx plus c, where x is the variable, a and b and c are constants, and a cannot be 0, so it has to have the x squared. This form is also known as the standard form, which we're going to be working with today, of a quadratic function where a is the coefficient of x squared, the quadratic part, b is the coefficient of the x, which is the linear part, and c is the constant. The graph of a quadratic function will be U-shaped, which is called a parabola. Now we're going to go over different characteristics of quadratics. The Y-intercept is the point at which the graph crosses the y-axis and is written as 0, y. The x-intercept would be on the x-axis and would be x, 0. The vertex of the parabola is a point that is the maximum or minimum, and I'm going to explain what those are. The maximum is the highest point, which means it would look like this. That would be a maximum. Or it could be the minimum, which would be the lowest point. So your graph would have to open the opposite direction in order to have a low point. The axis of symmetry is the vertical line that contains the x from the vertex. So it will be cut right down the middle. That's what the axis of symmetry is. So it'd be the x value on the vertex. Now today when we graph standard form, we're going to be using x equals negative b over 2a to solve for the x part of the vertex. Then we will substitute that value in to find the y. Just a little reminder, if this a in front is a positive, your graph will open up. And if it is a negative in the front, it would open down. We are going to skip example 1 and go to example 2. I have a, b, c. X is equal to negative b over 2a. I plug b in, I plug the a in. Negative 16 over negative 4, that would give you a positive 4. I plug it in to my equation. So I'm going to enter negative 2, parenthesis 4 squared plus 16 times 4 minus 30. Negative 2 times 4 squared plus 16 times 4 minus 30. That gives you a 2. That is your vertex. 1, 2, 3, 4, up 2. I put a dot for my vertex. Now with quadratics, the pattern that they have will be 1, 3, 5. They're odd values. So this graph, if I went up 1 over 1 and I used my 1, 3, 5, it would open up. But based off of this A, it should be opening down. So I need to use -2 from that front value to make sure it's opening the correct direction. So 1 times -2, 3 times -2, 5 times -2. That pattern is done being used. So now I will go down 2 over 1. Then I go down 6. 1, 2, 3, 4, 5, 6 over 1. Down 2 over 1. Down 1, 2, 3, 4, 5, 6 over 1. And that is the graph. Let's try example 3. I have a, b, c. X equals -b over 2a. -6 over 2 times, there's no number, so it's a 1. -6 divided by 2 is -3. And you don't have to show all of this work. You'll get pretty fast at it and you'll be able to start skipping. I plug that x in, so -3 squared plus 6 times -3 plus 9. Then I find my pattern, 1, 3, 5. I look at A, and because it's already a 1, my pattern does not need to change. It's fine the way that it is. So I'm going to open it up 1 over 1. Then I go up 1, 2, 3 over 1. 1, 2, 3, 4, 5 over 1. And then mirror up 1, 3, 5 so that it matches to make your parabola or U shape. Example 4, a, b, c, x equals -b over 2a. That's -8 over -4, which would cancel and become a +2. We plug it in. -2 times 2 squared plus 8 times 2 minus 9 is -1. +2 down 1. Vertex. Now I use my pattern. This -2 is going to make this one become a -2. 3 would become a -6. 5 times -2 is -10. So we go down 2 over 1, down 1, 2, 3, 4, 5, 6 over 1. And there's your parabola for example 4. So we have a, b, c. X equals -b over 2a. Plug in b, plug in a. 2 negatives make a +8 over 4, which will be a 2. Plug it in. Two times 2 squared minus 8 times 2 plus 4. Vertex. Now I use my pattern, and it should become, because of this 2, a 2, 6, and a 10, and they're positive. Up 2, up 1, 2, 3, 4, 5, 6 over 1. 10 would be off, so I get a stop. And then I mirror it on the opposite side. And that is how you graph quadratics in standard form.